Good morning, everyone. Internet of Things, Part 3. I am Mrs. Varsha Kiran Patil from ESC Department, AISSMS IoT. In first two parts, we have seen enabling technologies of Internet of Things. Also, we have seen how the Internet of Things have grown in past few years. Also, we have seen that is the definitions of Internet of Things. In this part, we are going to see sensors, comparisons of that is IoT platforms, and we are getting familiarized with that is Arduino IDE. For this lecture, prerequisites are students should know sensors, actuators, microcontroller, and mechatronics concept. The objectives of the this lecture is, as said, it is nothing but identifying the sensors and components and build a ecosystem for IoT, and for building the ecosystem of IoT to compare different IoT platforms to choose one of the best candidate from them. Also, we are having familiarization with Arduino IDE. Let us have the look upon few sensors which are used in the Internet of Things lab environment. Here is the relay that is used, again joystick, analog hall sensor, digital temperature sensors, tilt switch, passive buzzer, and very important candidate in this is temperature and humidity sensor, that is called as DHT11 sensor. Lot of variety of sensors are present, and we can identify them for our purpose. Mostly they are having V in, V out, and the ground kind of situations where three connections are required, four connections are required. Such a connection requirement is there. So it is very easy to interface these particular sensors in the physical layer of Internet of Things. In case of that is elements of ecosystem of IoT, the important component is choice of microcontroller. We will have the comparison of microcontrollers and which candidate is that is to be choose for which operation that we are going to see in a few minutes. Let us have look upon how these things occur in ecosystem. The stack of the stack of sensors take the data from physical environment and send towards microcontroller. From microcontroller, the data is sent towards various connecting protocol and communicating protocol. So connecting protocols are like Bluetooth, RFID, Wi-Fi, and WiMAX, GPS, GSM, etc. Also available technologies are satellite to WPAN. So while having such heterogeneity in the that is environment, the IoT must be having seven characteristics defined in first lecture, that is very large, sensing, then it has to be have intelligent. All these characteristics should be having along with seven characteristics, that is nothing but security, that we have seen in first lecture. So once this is connection between, first of all the stack of physical layer sensors to microcontroller, and from microcontroller towards these Wi-Fi or all these that is communicating and connecting protocols is done, then next it is given to the very important element in the ecosystem, that is nothing but gateway. From gateway, the signals are sent towards the server side. At the server side, such a actuators are present. In case of all these IoT platforms, which one is to be chosen and which one is to be that is discarded for the application, that can be done with the help of this particular table. The table says that these are the parameters, and the candidates in the race are Arduino Uno, Raspberry Pi 3, then ESP8266, that is called as Node MCU, Intel Edison, MediaTek Lincoln, and Udo Neon. Some of the candidates are taken into consideration and we can have the comparison. Now, in case of Raspberry Pi 3, very nice that is processor, quad core ARM Cortex is used. Now, again, the winning edge is given to Raspberry Pi due to its clock edge and clock speed and system memory. The system memory is in GB, whereas in case of other candidates, it is in either MB or either in KB. The other thing is that it is having the clock speed in gigahertz, which is again making it as a winner. So next is nothing but same Arduino Uno, Raspberry Pi, ESP8266, Intel Edison, and all other that is protocols are compared with each other. So while comparing, again, the parameters are nothing but we are having communication support. In case of communication support, that is most of the communication protocols are present in Meditech Lincoln kind of uh, microcontroller. But again, in case of Raspberry Pi, the winner edge is given due to these two characteristics. That is nothing but Linux compatibility is given in case of Raspberry Pi, and the programming languages that are available on Raspberry Pi are nothing but Python, C++, C, etc. So this is again giving the that is winning edge whenever the applications are fast and the Raspberry Pi can handle all this. Arduino Uno is also another that is practically used, widespread used microcontroller. Also, new candidate in that that is Wi-Fi enabled candidate ESP8266, also called as Node MCU, is again a that is candidate which is used in labs very that is popular. Here is the ESP8266 kind of microcontroller. So ESP8266, that is Node MCU, then Arduino Uno, and this is nothing but Raspberry Pi. The picture shows MediaTek, Media Lincoln, and Intel Edison also. So most of the time, most of the Wi-Fi enabled systems are using ESP8266 or Raspberry Pi. Most of the candidates are choosing Raspberry Pi because it can be used as a that is a small computer unit in which we are having connectivity to that is HDMI video processor video output, and also it can be useful for onboard Wi-Fi support and micro SD card support. So it is having capability to have the LAN port connection, etc. Again, in case of this Raspberry Pi, we are having 40 GPIO pins which are extended and can be seen by two purposes, either GPIO or other purposes in case of Broadcom kind of thing. Okay, so we are having 1, 2, 3 popular candidates from IoT ecosystem. Now, from hardware to software, most of the, as we have seen previously, most of the most of the microcontroller are compatible with Arduino IDE. Let us see here. Here, Arduino IDE compatible are all the that is microcontroller except Raspberry Pi. So we have chosen here that is how Arduino IDE looks like. So to download Arduino IDE, go to arduino.cc where you can see this website, and on this website you can see the documentation. In the documentation, tutorials and all support is there via blog or via community. We can post our that is problems also. Let us see one of the program. The program in case of Arduino IDE, it's called as Sketch. In case of Sketch, we are having menu like File, Edit, Sketch, Tools, Help. Out of this, we can have here verify button, upload button. Once we verify our program, it can be directly uploaded on Arduino Uno or Arduino kind of Arduino microcontroller series. So this is very easy interface to use. The structure of the program is also very easy. Let us see how the program that is called as sketch in case of Arduino IDE is arranged. In the sketch, there are two parts. First part is called as void setup, and second part is called as void, that is nothing but loop, void loop. So what is meant by void loop? Void loop is declared once at the beginning of the program or sketch, and it does not, that is never we are going for again and again use that. Here we are having only one time it is working. After after executing these lines, the program goes to void loop. Once it goes to void loop, it runs over and over and over again. Okay, so whatever output we are getting related to compiling status, memory uses, or that is warnings that is seen in this window. So this is the structure of Arduino IDE. Let us see hello world of hardware. Hello world of hardware is nothing but LED blink. Like in software we are writing hello world, in hardware we are writing LED blink. So what is LED blink? That is nothing but we are making LED low and high. So very easy thing is here, in which we are first of all declaring that is what is LED, that is one variable, and that variable is defined towards one pin, and then we are writing pin mode. Now in case of pin mode is important because it is useful for declaring the pin to be input or output, and it is written as pin mode, that is pin small m is, that is capital. And then once we declare LED as output pin, then we can write it, that is high or low, using the statement called as digital write. So digital write is a statement which is useful for writing the output level to be high or low, and in between we are adding, that is delay of 1 second, by writing delay 1000. So this way very easy programming structure is there in case of Arduino IDE. So let us have summarization of today's lecture. So after doing these all exercises in the lecture, that is we can name and identify few sensors from that prototyping lab of Internet of Things. Then we can have, that is explanation of elements of ecosystem of IoT. In case of that, we have seen gateway, then heterogeneous communicating and communicating protocols. Also, we have seen that is nothing but number of sensing elements, and then actuators also we have seen. Then we went to comparison of different IoT protocols. We have seen that Raspberry Pi is mostly winner in case of, that is networking applications. Also Arduino IDE and Node MCU are, that is ESP8266 are popular one. Also we have seen Arduino IDE and one small program for that is LED blink. So we have seen all the that is IoT ecosystem in this particular lecture. Thank you very much for, that is uh, observing all the